Good morning, everyone. Good afternoon to some of you on the other side of the pond. Like Michelle said, we're going to be talking about Windows 10. In fact, why don't I just jump right into the agenda? But before I do, my name is Patrick Brennan. I run all the product marketing basically here at Atlantis. My background is in the desktop virtualization space. I actually, in a former life, was an architect at Citrix and then did a bunch of consulting work before that. So I know the technology stack very well, and I've been in the space for over a decade. So let's talk about, exactly what we're going to be covering today, which is first just talking about Windows 10, talking about where we sit today with Windows 10 and what the market looks like, and talk about why why customers are choosing to migrate. And then we'll talk about the migrational challenges as well as the operational challenges as it relates to transitioning from those previous operating systems and getting up to date with Windows 10. And we'll then move on to talking a little bit about VDI, what it provides from a value perspective for changing the end user computing model, and then move on to what that looks like with Atlantis powering the virtual workspace, as we've coined and phrase a lot, as far as VDI not being just desktop infrastructure, being more of a virtual workspace that extends to applications, desktops, and just providing mobility to your employees. So when you look at Windows 10 today, it's actually the fastest operating system by adoption from Microsoft over any other previous operating system. So if you look at how fast it's growing in adoption rates, it's already 140% faster in terms of adoption than Windows 7 and 400% over Windows 8. Well, we know why Windows 8 didn't really take off too well, but I mean, the point is that it's definitely one of the driving factors, the things that enterprises are paying attention to most to try to get up to speed on in terms of the latest, greatest offerings from Microsoft and the operating system. So there's already 350 million devices that are running Windows 10, and we just recently had that anniversary date of 1 year. So that's quite compelling when you look at how quickly the adoption rates are going for this particular operating system versus going from XP to Windows 7 was really challenging in terms of how fast customers were moving and migrating. So when you look at the enterprises and the business numbers, like I said, when you looked at like going from Windows XP to Windows 7, within a 6-month period, you would see very dismal numbers. And according to Spiceworks, they did a survey with customers, and they saw that within 6 months, customers are already rolling out Windows 10. At 18% had already done some sort of implementation work into their enterprise. And the larger the enterprise, the more resources obviously you're going to have as far as IT infrastructure and support go. And so that said, there's the larger the companies had higher saturation penetration rates for Windows 10 adoption, but even smaller companies were starting to already roll that out. So it's definitely something that enterprises are looking at doing. And why are they doing this? So I don't know if you're familiar with this, but a lot of customers I talk to don't really know, but Windows 7 is actually already out of mainstream support, which happened in January of 2015, and extended support actually ends in 2020. So Microsoft is expediting their support cycles and really shortening those support cycles so that there's this more rapid innovation and people actually adopting those operating systems faster, so we can get off the old stuff and get onto the new stuff. And speaking of old stuff, inherently supporting old stuff is very expensive to do. In fact, the U.S. Navy is still today paying Microsoft $31 million to support XP until 2017. So they're forklifting, all this additional money just to stay and give them additional time to migrate to XP. So there's definitely some challenges there, and a reason amongst others, to definitely migrate, because nobody wants. It's just so expensive to continue to support that antiquated infrastructure. And when you think about it, in IT, we're here to innovate. At the end of the day, we really are trying to provide value to our businesses as well as our users. And staying on the old stuff doesn't really preclude us to being able to innovate really well. And you don't want to get left behind as a result of that. In fact, they're saying, according to Gartner, 50% of enterprises will have actually started deployments by 2017, and many have actually started the second half of 2016. So the numbers you saw were within the first 6 months of implementation. Now, with the second half of deployment cycles, the second half of 2016 rather, there's a lot more enterprises that are moving towards actually deploying it, right? So the other thing too is, as us as consumers, right, we're used to getting a new device and having the latest, greatest technology and operating system on those devices. Users are now expecting IT to be just as fast and agile. Nobody wants to, go home and use their Windows 10 device and their tablets and everything else, and then go to work and using an old operating system with antiquated software. It's just not what users expect these days, right? So summarizing, basically some of the adoption stuff, Gartner quoted this a couple months back that, if you're not getting it, you kind of see that Windows 7, implementation and adoption is significantly much faster in adoption rates for one operating system to another than it was with Windows 7 6 years ago. Now, when you look at the migration challenges as it relates to migrating from one operating system to another, it's very difficult, because you have to, look at all of your assets that are existing today and make sure that you have drivers, you have applications, will your devices support this hardware, these updates, will it support Windows 10? All that stuff takes time, and you've got to test all that and validate it, which it just consumes so many cycles to do that. The other thing you've got to do is go through and try to reach every single endpoint, all these devices in the enterprise, and you've got to somehow be able to reach all of those, deploy and update those as centrally as possible. In some instances, you have to go to the endpoint physically, which is even more challenging, right? To do that. And meanwhile, after you've tested it, you validate it, you've got a way at a deployment model to reach every endpoint. Then you have to do all of this without disrupting the user, which is extremely challenging. Ensuring that they don't lose any data, they have the same experience whenever they transition from, let's say, Windows 7 to Windows 10. All those things are just difficult to do. And when you look at the traditional model, and this is basically what IT has been doing, for since the beginning of enterprise type deployments with supporting end user computing. You've got to procure it, image it, secure it, deploy it, all these things that just take up time, and everything is. And the reason why that is because you have your hardware, your operating system, and apps and profile, and all that user data is all coupled together. So if you change one of those things out, usually you have to look at the impact as a result of that can impact one of the other things. So if I change my profile, how's that going to impact the usability with that application? Or, if I change the application, how's that going to impact my user data? Is it going to be still supported in this new application? All those things are very difficult to pinpoint and kind of nail down. So when you look at the operating system itself, Windows 10 has implemented a different policy as it relates to supportability. So no longer can you permanently defer Windows 10 updates. So previously with WSUS and technologies that help with patching and updating, you could defer patches like with Windows 7, Windows 8, because with the deployment tools, the enterprise deployment tools that are available, you can say, well, I don't want this to ever be deployed in my enterprise because it's detrimental or something along those lines. But Microsoft actually has, I believe the timeline is 8 months to where you have to implement some of their hotfixes or updates that they have. And when you look at that policy, here are some of the, Windows 10 has these updates where they do cumulative updates, which are basically normal patches that you're familiar with, but they also have what are known now as feature updates, which are more or less, I don't want to say service packs because that's probably too encompassing, but it's kind of somewhere in between hotfixes and a service pack. And when you look at some of the recent feature updates that they've provided, I just took some examples that you can see in Google for yourself that are out there, but these are some of the causes or some of the things that these updates have caused, where users can't even log in or they have driver incompatibility issues. Well, those are probably more obvious, right? But things like Windows stores, if you're using Windows Store for some of your applications, that crashes. Corporate lock screens, which is very important to some enterprises out there, being able to provide some sort of EULA or some sort of disclaimer before you log in, suddenly didn't show up anymore. I've actually had this problem myself where I run out of storage space. So if you have a situation where you're like myself and you dual partition your disk, and maybe you make a small partition for your OS and a large partition for your data and apps, you can run out of storage space, and Windows doesn't tell you. It just pushes down those updates, and you look at your C drive and you go, wow, like why am I suddenly out of C drive space? It doesn't make any sense. And meanwhile, in the background, Windows 10 has been pushing all these updates, and you didn't know it. So it's pretty frustrating, and some of that has been resonated up to Microsoft, but they've been very bullish in terms of what they, how they want to move forward with IT in terms of pushing their updates and patching the operating system much faster and getting IT to basically adopt a more rapid deployment model. And that puts a lot of stress and burden on existing IT infrastructures who aren't necessarily equipped to handle this, whether it be they don't have the tools, they don't have the resources and people and manpower to do all that. There's a lot of reasons. And so when you look at it, just doing the same old thing is just going to get you the same results, and it's going to be a slow, clunky type end-user computing model that people are used to. And like I said, they don't want that anymore. The way that innovation is happening with IT, it's much more rapid than the way we used to do it. So then VDI came along, and it was supposed to resolve all these things, right? So I'm going to talk about VDI a little bit from the past tense perspective, because the VDI came and a lot of customers adopted it. Some still didn't hold off, and we'll talk about why that is and how some of those challenges were alleviated today. But VDI was supposed to basically provide more of an on-demand assembly of user data, applications, and operating system. It's supposed to provide basically a layer cake approach, and then provide any type of device, whether you had a laptop or an iPad or whatever it was, you would just provide a connection point into your infrastructure, your desktop infrastructure, and users would be able to get all that, which was great because it centralized everything, and we'll talk about all that here in just a minute. But that was the idea and the approach. It was to provide a modern end-user computing model. And the benefits were profound, right? So you could easily suddenly turnkey a branch office by deploying a little bit more infrastructure and just setting up some dumb terminals at the endpoints. You could onboard a new employee much, much quicker because you just say, here's your dummy device, whether it's a laptop or thin client, whatever it is, and we manage all the infrastructure and deployment at the end, or sorry, in the data center. Applying security patches and updates are much, much quicker with VDI. So, you're able to, because you're able to take and leverage the functionality of centralizing all that stuff. All those things get done much more quickly, as well as your testing and your deployment models as well. So, and that goes back to the power of centralizing, right? So being able to have one image that basically gets deployed on your infrastructure, and then whenever the user logs in, it applies that profile based on who they are, as well as delivers the applications as well. So if you're Susie May from finance, you log in, it gives you your profile on demand, and then assembles that, oh, okay, you are in finance, so you get this subset of applications. So all those three things are now decoupled and assemble on demand, which is much easier to manage each one of those different components on its own. And if you change one of those things out, it allows you to still maintain that same level of consistency and mindset as you make changes anywhere in that stack. And the way that was delivered from an infrastructure perspective was you basically had a single image, and then all of your Delta changes would be delivered to a Delta disk. So any type of changes or whatever you had two different models. You had a persistent model or a non-persistent model. And in a persistent model, those changes would be kept so that users would have some sort of level of personalization. Although, again, with profile management and other type UAT models, you can provide that level of persistence even with a non-persistent type image. But the idea was if a user wanted to install an application or something along those lines, you could allow them to do that, but still manage the base image and update that as often as you needed to. Then you had the non-persistent model, which was more of the approach of every time that operating system or that VM was to be rebooted, all those changes were gone. And the way that the data was persistent was, like I said before, with profile management and layering on those data and applications on demand. So the problem with that, though, is that all of those benefits sound great, right? I mean, we all want to be able to be a little bit more agile. We want to be able to onboard our users faster, and we want to supply our users with that capability and functionality. But the problem was, now you had this big infrastructure. What do I do about my storage? Now I got to create all these, networking VLANs, all these things, and I also have to make sure I have enough compute and virtualization. I got to manage all of that infrastructure, and now I'm shifting the complexity. So instead of having all my devices that I'm managing, now I've got this super complex infrastructure where I've got tons of SAN storage, tons of networking, tons of compute to deliver a subset of VMs. And historically, especially right when VDI started to enter the marketplace, storage has gone through a lot of changes and iterations in terms of what it was back then and what it was today, or what it is today. Because back then, everything was more along the lines of, everybody ran out of capacity more than anything. Performance was less important. It was important, but it was definitely less important. And the way you solved that challenge was you just, added more stacks of spindles to it, which gave you a ton of capacity that you may or may not have needed, but really you needed the performance because, desktop virtualization is nothing like server virtualization, and it really changed and shook things up from a hardware perspective as a result of that, and really drove a lot of new innovations in that whole market. So the whole point was that, with VDI, it really shifted complexity. So when you look at what was end-user computing solved, well, we did make end-user computing more simple. We made it faster, being able to make all those changes and updates and everything like that from a centralized perspective, and not having to make sure that, this application worked on this device. If you had, 20, 30 different types of devices in your environment, you had to make sure that all that stuff worked on all those different platforms that you supported. So this allowed us to be much, much faster because everybody was, standardized and had the ability to change out operating systems much, much quicker, applications and all those things that we mentioned. And then, again, going back to the easier operating system and app management, I mean, when you have a standard platform that you're delivering an image on, making if you were to test a patch or an update from Microsoft, for example, you didn't have to worry about it affecting all your different devices, because all you had to do was just make sure that that standardized VM received those updates without fail or without any cause or issues. So there was only one platform that you really had to test on, and allowed you to get your patches and updates and your development cycles reduced in quicker time to value to not only your IT infrastructure but also your users as well. So the problem is it didn't make infrastructure simple at all, and it didn't make it very cost effective, which were the two primary barriers to adopting desktop virtualization at VDI. And all of that basically, or a lot of it, has changed significantly as a result to a lot of the technologies and innovations that are out there. And Atlantis is really leading this space quite significantly because of the value that we're bringing to these type of workloads. So the way we do that is we have two different types of offerings to solve the challenge of making infrastructure much more simplified and making the cost of adopting this technology simple as well. So we have a software-defined storage approach, and we have a hyper-converged appliance as well. So if you're looking at adopting the virtual workspace, and you're looking for like a turnkey type solution where you need to not have a bunch of cycles wasted on deployment or anything along those lines, this is a really good use case for remote office, branch office type deployments, as well as like I said, if you're looking for more of the modern style of data center, we've got Atlantis HYPERSCALE, which is a hyper-converged appliance, so we'll talk more about that here in just a moment. And then you've got Atlantis USX, which is our software-defined storage component. So basically what Atlantis USX does is what I would say hypervisors did for server hardware. So when you look at SDS, or software-defined storage, we're basically taking physical hardware storage, and we're virtualizing it, like I said, similar to how hypervisors and VMware did to hardware, and we'll talk about these two more in depth here. So one thing that's important to note is that USX and HYPERSCALE, both of those products, actually won Best of Citrix Synergy this year. So these, in the two categories that these products were submitted in, they beat out the other candidates that were up for it. So we're really excited to announce that, and really proud of that Citrix relationship, which continues to get stronger every day as a result of the value that we're bringing to Citrix solutions and just the overall virtual workspace. So I'm going to build this out, but again, the HYPERSCALE appliance is basically an all-flash hyper-converged appliance. And it's significantly less expensive than doing things the traditional way. And so it's an all-flash appliance that's relatively inexpensive, especially, like I said, when you can traditional computing or other hyper-converged vendors out there. We have this available in various vendors such as HP, Lenovo, Dell, Cisco as well is included in that, as well as Supermicro as well. And it gives you that modular scalability to basically, pizza box in and add users as you scale and as you need them on demand. And just a little bit about Atlantis and the hyperconverged space. In the area of desktop virtualization, we've got over 1 million seats deployed as it relates to the virtual workspace and desktop virtualization, and we actually are the leader in hyperconverged solutions as it relates. And when you look at our market share for desktop virtualization with hyperconverged, we've doubled our market share year-over-year growth. So not only are we the leader in it, we've also continued to expand our market share in the hyperconverged space for desktop virtualization. So backing up a little bit, if you're not familiar with hyperconverged solutions, basically, as I mentioned earlier, with traditional desktop virtualization, as we adopted that model, you had all of this, all these different pieces and components that you had to put together. That was really complex. You had to have a storage team that really knew what they were doing, as well as you know, a lot of storage to support that model. You also had to have all the servers and the compute infrastructure to support those things, and then the networking infrastructure as it relates to storage and compute, and tying all that stuff together was very complex. And when you look at hyperconvergence, what that does, especially with hyperscale, is we take that compute, the storage, the networking, and then the virtualization hypervisor layer, and we put it all together into a single box that provides highly available solution that provides you also the same enterprise features and functionality that you would get in a traditional SAN today. So when you look at things like snapshotting and replication and teleporting between, you know, one data center to another, hyperscale provides you all that same capability and functionality all in a single box. And what's cool about it is it gives you modular scalability, as I mentioned earlier, by when you deploy this thing and you decide to build it out, it's simply answering 4 questions. That's all you got to do. And it automatically provisions the box based on your environment. Do you want it to integrate to your existing infrastructure? Do you want it to, you know, deploy on its own? Do you want to build out a new cluster? You know, and being able to do that in small building blocks and grow and pay as you grow to you know, grow out that infrastructure is really a compelling story, and really allows you to keep your data center simplistic, consolidate it, and reduce the amount of footprint to deliver that same infrastructure. So now that very complex model that we talked about is simplified and converged into a single appliance that you can just add on as you go. So now talk about the Atlantis USX software-defined storage strategy, because this is actually something that a lot of customers don't quite understand. You know what USX is. They may have heard about it. Maybe they've even heard of what's formerly our product called Ilio, which was a product that was used to solve the specific case of, you know, desktop virtualization and storage and that kind of stuff, which matured into Atlantis USX, which was a general purpose storage. Not only does it have all the functionality and capability delivering you know, the same functionality that Ilio did, but also allows you to put your entire infrastructure on it, whether it's, you know, supporting infrastructure for desktop virtualization or databases and that, all those types of activities or use cases and applications. So the point is that USX is a software-defined storage that sits in front of any type of storage that you have. So if you've got an existing SAN that you're heavily invested in, we'll sit in front of it and be able to repurpose and add additional capacity, extend the life of that storage. So even if it's flash, we can actually increase the performance of that as well as add additional capacity. So the idea is to be able to take, whether it's a mix and match of any kind of storage you got, whether it's local, DAS, SAN, NAS, it doesn't matter. We can take and aggregate that storage and present it as shared storage to your infrastructure and have your VMs sit on it, which is a really compelling story because a lot of our customers that we talk to have a mix and match of hardware. So they may have, you know, an AMC that they've invested in, and, you know, at some point they have this old NetApp that's sitting in the back somewhere that they don't want to. They don't want to. They have the capacity. They have the spindles. They're invested in it. They don't want to just get rid of it, but they also want to modernize it and be able to leverage and squeeze out that ROI out of that heavily invested solution that they, you know, spend a bunch of money on. And we could do that. So we could take all those different platforms, and like I said, also if you've got local storage and spare capacity that's just sitting there in your servers today, we can take that and present that as shared storage and now provide enterprise class data services wrapped around it. So like I was mentioning earlier, we have the snapshotting, the provisioning, be able to provide replication between sites, and present that as a NFS optimized data store or an iSCSI data store as well, excuse me. And the two things that really make USX compelling are the ability for us to provide an additional capacity and that increased accelerated performance. And the way that works is that our volumes that are optimized with our software of Atlantis USX are doing inline data deduplication as well as I/O acceleration and caching. So as writes are coming down the path, the I/O path, we're able to identify if that write needs to actually be written or not. And if it doesn't, we can toss that write because of our cache and dedupe and tell the operating system, don't worry, we got it, proceed as you were, because we've already written it before. So it doesn't actually have to get written down to disk. Now, the reason why that's really compelling is because when you look at a single write, one write is not actually one write. Because we have parity, because we have RAID and all of those things, one write could be 2 writes, it could be 5 writes, it could be 10 writes. It just depends on how much parity and what your failure domains are and your fault tolerance and how you have all that stuff set up. So when you aggregate that and you look at what the performance looks like as an impact of that, suddenly now you've got all these new IOPS, or you've got a significant increase in the amount of IOPS that you have available to you. So this is actually a representation of a real customer environment that we took screenshots of. And over on the left, you see that capacity is basically full, and this is the actual screenshot of the I/O before of the VMs before Atlantis was put in place. And then whenever Atlantis USX was adopted and put in place, you see that the IOPS dropped significantly, as well as we provided that increased storage. So in a desktop virtualization model, usually we're able to provide, on a persistent model, we're able to provide usually at least 80% additional capacity in terms of your overall storage capacity, and give that back to you so that you can use that capacity for other things. And in non-persistent models, it's 90% plus, because there's really not a whole lot of unique data that we see. And so because we're saving you in capacity, and because we're saving you in terms of all that performance that you now get, your infrastructure looks like when you put in HYPERSCALE or USX, which, by the way, I neglected to mention this until now, but HYPERSCALE actually runs on that USX platform underneath the cover. So we're still using that same engine to provide all the same data services and functionality to give you that additional performance as well as the additional capacity. And we take all that complicated infrastructure and we simplify it down to reclaim and give you back, like I said, like 80–90% of your storage, so that you can manage a lot less and deliver the same and better performance than what you are today by trying to solve the problem from a pure physical perspective. So the other benefits as a result of that, with the increased IOPS and all that functionality or that increased performance that we're giving you, we see a significant reduction in login times, which creates a much better user experience. So we, in one of our customers, Royal Orthopedic Hospital, they had their login times reduced by 81%. So they had users that were taking up to 5 minutes to log in, and we were able to reduce that significantly and allow a much better experience so that those doctors and those nurses could spend more time on patient care rather than waiting for their machines to log in. And there was a real value to that. I believe they calculated out, exactly how much that equates to a cost savings for just overall personnel savings of time and patient care, which was a significant savings. And then we also provide, as a result, a consistent user experience. So even when your users are really hitting the infrastructure and hammering away at doing whatever it is that they're doing on the desktop, a lot of times with old or just traditional storage, you would see a lot of IOPS get hit and hammer the storage to where it was out of IOPS as a result of that. So USX actually has a capability to where we can provide theoretically unlimited IOPS depending on how you set up the infrastructure, but it's very simple. All we have to do is just create another volume, and we can add IOPS to an environment, which is pretty neat. So even during peak usage, we can provide a consistent user experience because we don't really run out of IOPS. We provide tons and tons of IOPS for those users. In fact, whenever I was doing the reference architecture testing with VMware View as well as Citrix Zen Desktop on the HYPERSCALE appliance, we calculated it out to be about 250, 300 IOPS per user. And when you look at a traditional desktop today with a spindle, users usually get somewhere between 50 to 100 IOPS. So we're providing 2 to 3 times more IOPS on that specific model of HYPERSCALE, but we can spin up more storage and more volumes to make that even more faster. So users, at the end of the day, are actually going to get a much faster and superior user experience than they're getting on their PC, because when we have more IOPS available to us, we're also able to provide application launch times that are much, much faster as well. So where this really shines is whenever you're talking about opening up, let's say like a large Excel file or a PowerPoint that's really massive. In that instance, that can take quite a bit of time, especially for the finance folks who may be on the call. You may see that opening those things can just take a bit of time to do that. And when we have all those IOPS available to us, we're able to launch those applications much, much faster, and in most cases under a second as a result of that. Now, with the additional performance and the additional capacity, what you get basically versus a traditional storage array is a significantly lower cost as a result of that. Because we're fronting in that storage, you need a lot less disks to provide that same level of performance. You need a lot less hybrid storage. Excuse me. You even need, in a lot of cases for all-flash arrays, we set in front of all-flash arrays for a lot of customers because we're able to increase the capacity of the all-flash array as well as provide additional level of performance because we're able to save all those writes that would otherwise be written and really allow those who have heavily invested in all-flash arrays to reclaim that storage and extend the life and get some more value out of that all-flash array that they purchased. So when you look at the cost comparisons between, so what I showed previously was basically, our USX software-defined storage strategy versus the other, doing it from a hardware approach. When you look at it from a hyper-converged solution perspective, it's significantly less as well. Now, this is our 96-core, 1 terabyte of RAM, 12 terabytes of storage. This is a huge, very powerful box, which is why you may have sticker shock if you see that. But there are definitely other models that we have that are less expensive, so that if you're trying to have a lower barrier to entry or doing other types of workloads, you can definitely have a box that's more suited for that specific use case. But the point here is to just show you that when you look at doing things the traditional way, it's significantly more expensive. And then when you look at other hyper-converged appliances that are out there as well, we are much less expensive when you look at those as well, just because of the value add, again, that we're able to provide all that functionality, performance, and capacity without having to spend a bunch of money on hardware to deliver the same level of performance and capabilities on other appliances as well. So if you'd like to, we actually have a cost calculator on our website at atlantiscomputing.com. You can go out there and actually see the savings, not only from a hyper-converged versus hyper-converged perspective, but also you're looking at it from a traditional storage plus server type combination. So with that said, when you couple these solutions and you look at the new virtual workspace today, all of the requirements basically get met. I mean, you have your infrastructure is much more simple. You no longer, like I remember back in the day, like you had to create all these different LUNs for like 20 desktops. So you could only put like one LUN, 20 desktops on that LUN, and if you had a huge infrastructure, that takes forever to match up those VMs to that LUN, and then you'd have to create all these LUNs for all that storage and map all that stuff. That was so complicated and complex, and matching all that with your compute layer as well, being able to simplify that. One thing I forgot to mention is that with the USX software that I was talking about earlier, you can actually develop and roll your own hyperconverged solution. So if you don't want to use the hyperconverged offerings that we have today, you can actually take USX, because I mentioned earlier about USX being able to leverage local storage, you can take USX and actually develop your own hyperconverged solution using USX to really simplify that infrastructure and converge it all into one single box, which is pretty compelling. And again, now you've really reduced that price point. So when you look at it from a hyperscale price point for cost per desktop, we've got that price point down because of the converged infrastructure and all that capability of what our software is doing under the covers to about $150, a little bit less than $150 a desktop, as well as if you're running more of a XenApp shared hosted session type workload, you've got that price point down to under $100 a desktop, because when you're looking at shared hosted desktops on a single VM like with XenApp or RDS terminal services, you get a little bit more economies of scale. So that being said, you get that additional cost savings as a result. So from an infrastructure perspective, that's significantly cheaper, because when a VDI was first introduced to the market, it was about $1,000 a desktop to deploy the infrastructure to support those users. And suddenly, it just wasn't all that compelling. So sure, I get, my end user computing is simplified and I'm more agile, but man, that's just not cost effective. It's just too expensive to do all that. Well, since the inception to where we are today, there's been so many technological advances. We now have the capability of doing turnkey appliances with hyperconvergence and simplifying all that stuff to where now doing VDI and adopting that and using this as a time to adopt Windows 10 and move to that more agile model is actually cheaper than buying a new endpoint device and then supporting that and deploying all that. Even whenever you consider additional licensing costs from whether it be Microsoft or Citrix, et cetera, to add their license on top of that, it's still cheaper than going out and buying a bunch of new PCs and then imaging them and continuing to do that same model that you may be used to. So it's a really good time to look at adopting the virtual workspace at this point in time, because the technology finally is in a point where it's able to support that as a Main Street type model instead of a niche thing that you're kicking the tires with or something that you've just kind of, oh, that'd be nice to have, but man, that's just too expensive. Windows 10 is really a catalyst to help look at taking this seriously and adopting that model. And with 3.5, we've actually continued to enhance a lot of the workspace functionality. We've simplified management yet again by adding some capabilities that are actually specific to workspace and those type of workloads. So I would encourage you, I'll link the blog here in just a moment, but I would encourage you to go check out some of the information out there as far as what we're doing around the workspace with enhancements with 3.5 and simplifying and easing the management for that. We've also provided some new functionality capabilities, as you would expect to see in any enhancement, really. And we're also using even less hardware than previous versions. And I'll talk about that here in just a second, what that means. So one thing that's cool from a new feature perspective is the ability to add your own plugins. So we've actually enabled it to where if you're doing some custom workflows that are relevant for you. Maybe you want to query performance data for your volumes, or you want to query VMs and how many VMs are in a volume, and if they're powered on, and those types of things. You can actually develop your own tools and add that into the console and provide a GUI for a repetitive task. So you could say nodes, 1 through 5. I want to see, what the performance data looks like from those. You can just bring up a GUI interface that's presented to you from, leveraging the plugin tools and capabilities to deliver that custom workflow for you guys that's relevant to your environment. Now, from a less infrastructure required perspective, I wanted to touch on this because we continue to innovate. We continue to try to provide more functionality, more performance, more capacity with less infrastructure. And we've been able to do that in this release by one of the things that we use for some of our performance and data services and acceleration is use a little bit of CPU and memory to provide some of that functionality. And we've reduced our memory requirements by 40%, which is quite significant reduction in terms of how much we're actually consuming. Hybrid volumes are basically the ability to provide that performance, front-ending basically your SAN or NAS or shared storage that you have significantly invested in, front-ending that with our USX software to provide that performance and capacity savings in between there. Those are what hybrid volumes are used for. And we've reduced the amount of requirements for providing our resource requirements to provide that functionality and capability by 95%. So that's a significant reduction. The other thing too is we've reduced our snap clones requirements as well. So what a snap clone is basically, one thing I didn't talk about today is that we're able, and this is very unique to USX, nobody really has this capability other than us, is we could provide, and this is valuable for non-persistent workloads like non-persistent desktops, or even if your guys are entertaining Docker or that type of functionality and those new technologies that are out there, we could provide non-persistent data, or sorry, a data store in RAM, which is actually the fastest way to deliver storage for any type of workload. So if you've got a non-persistent workload that doesn't really need persistent data, we can use RAM and present that as a data store for your VMs to write to, and to provide some level of persistence for like non-persistent data. So what do you mean by that? Earlier I showed you how when you take a non-persistent image, there's a delta disk, there's a differencing disk that needs to be maintained. Although, albeit that it gets destroyed upon reboot, there's still disk files that are associated to that. So if you're running that into an all RAM type configuration, you need to have at least the ability to offset and store that disk into some sort of temporary or persistent storage. That way, if you lose a host or something happens to it, you can repopulate that RAM storage volume with the disks that were stored in there. Even if they're very small, they still have to exist. Well, the point is that we do snap clones for that. So we basically take a snapshot of that and keep that as a temporary data store and on persistent storage. And we've been able to reduce that. So the point is that overall, we're continuing to innovate and make sure that we use less and less infrastructure to provide that same level and more value as a result of adopting and using our software-defined storage. And these capabilities are also, because like I mentioned with HYPERSCALE, these capabilities are in HYPERSCALE as well, because HYPERSCALE is leveraging our USX platform underneath the covers. So that's pretty much the gist of it. I mean, I hope you understand and have some takeaways that, previously, if you look at VDI historically, I totally get, especially coming from that space and living that space for so long, that there were a lot of challenges with VDI, and sure, it was compelling, and sure, it was interesting, but really, it was challenging and tough to swallow because it was so complex, and it was so cost prohibitive to do that. And we've been able to solve all that with you know, our hyperconverged appliance with a turnkey approach, and then USX for really consolidating your data center and consolidating that approach and getting rid of having to manage all of that infrastructure and allowing you to extend the life or repurpose your existing storage. So if you're looking at you know, adopting a virtual workspace with Windows 10, this is a really good, like I said before, it's a really good time to do it. Have USX front end your existing storage, so that, which is pretty neat. So you know, when you think of, okay, if I'm going to adopt VDI, I've got to, you know, put in and roll in all this expensive new hardware and infrastructure to do that. Well, you don't. You can use your existing infrastructure that you have today and repurpose it, even if it's spindles and you know, what is considered clunky old technology. You can front end that with USX. So some things and considerations to think about as you do that is, what is the impact for those of you who are running a VDI today or looking at migrating to Windows 10, or if you've never done that before and you're using the the traditional end user computing model. There's IOPS considerations that are out there, which we talk about in this white paper that is really popular from our that was put together by our Citrix technology professionals. Sorry. So we have what are known as Citrix technology professionals here at Atlantis, basically industry experts as it relates to the virtual workspace or virtual workspaces that are provided by Citrix or sit on Citrix technologies. We actually have 4 of those here at Atlantis, so that they put a lot of interesting collateral and materials out there to help you with challenges and considerations as you look to adopt this infrastructure. But you'll find that the value that we add and provide really alleviates a lot of those challenges with IOPS considerations and making sure that your users have a really good experience as you adopt and move and migrate towards this new style of end user computing. And we actually have some blogs to support some of these topics as well. So we've got a Windows 10 IOPS blog. We've got, if you want to go in depth, and I really encourage you guys to do that, to look at the features and functions that I barely touched on them today with 3.5. But if you go to our blog on 3.5, there's a really detailed information about what those features and benefits are and what they look like and how to deploy them and leverage them and make the best use of it in your environment. And I would really encourage you guys to contact us for more information as well as demos. So if you want us to visit with you and show you what this can do in your environment, or if you want us to do a proof of concept and come on site and show you what we can do in your environment, and we can do that. So just go to atlantiscomputing.com/workspaceinfo, and we can take a look at it and have some suggestions for you and show you what we can do. So we have a few minutes left, so I was going to take some questions, and I see some here in the questions panel. So just give me a second to review those, and I will read them back to the audience so you guys know what we're looking at. Just one second. So the question is, can you take advantage of roaming profiles within an organization? So absolutely. In fact, we can provide those same data service benefits that I was talking about with our storage, USX storage, whether it's HYPERSCALE or USX. Those can sit on a USX data store. So if you're familiar with roaming profiles, basically what happens is when the user logs in, they get their profile information from a central data, usually it's a SMB share. We can have that SMB share sit on a Atlantis USX volume, which will provide that same level of performance and capacity savings. So we'll find a bunch of duplicates because a lot of the roaming profile information is duplicated between one user to the next. So we'll give you back a bunch of capacity, but most importantly when it comes to roaming profiles is that performance of being able to provide a quick, fast user experience, and that takes IOPS to deliver that experience. So when we copy the profile to the virtual desktop, we're able to do that fast, and then when we save it back to that repository, i.e. the SMB share that's hosting the roaming profiles, that data will be written really fast because of our data services that we're providing. Will the software perform continual optimization on the laptops and desktops? So yeah, I mean, absolutely. So what we're doing with our software is optimizing the I/O path between your storage and your VM. So as a result of that, every time an IOP is written or any type of I/O is written between those two points, we are optimizing it and inspecting it and deduplicating it, and as a result, over time, as you use an operating system, right, or any PC or VDI desktop, typically you'll get more and more IOPS because you're going to be installing more things, you're going to be pounding the VM, and especially if you're running antivirus, that you chews up a lot of IOPS to check and inspect every single detail of the operating system that's being written. And as a result of that, that requires a lot of I/O. And like I mentioned, if you need more IOPS, and this is better suited with a conversation with one of our solution architects, which again I encourage you to go to /workspace info to have us have that conversation with more in depth on how we do that. But basically we could spin up more IOPS on demand by using a little bit of compute and RAM with our software to deliver another 60,000 IOPS and be able to put VMs on that and give you more IOPS as it relates to your infrastructure. So you run out of IOPS, no big deal, we'll just add a volume and off you go running. So 60,000 IOPS is significant, and plenty of IOPS definitely for your desktops. And if you saturate that some way, somehow, like I said, you could just simply add more. I don't see any other questions. I encourage you guys to, like I said, check out some of these blogs. Take a look and look at some of these IOPS white papers, the blogs, the USX 3.5, and then, like I said, if you need more information, we'd love to chat with you guys more about what we can provide for your environment and help you with your migration to Windows 10. So with that, we are at the top of the hour, and we'll go ahead and adjourn. We appreciate your guys' time and hope to work with you guys in the future. Thanks again. Take care.